Hi, my name is Gabby, and today I'm going to be talking to you about reducing childhood overweight and obesity. My personal interest in this topic stems from the continual debate about sugar. Is it bad for us? Should we cut it out entirely? What about all the advertisements our children are exposed to? The need for some solid evidence for the connection between sugar and weight gain is obvious. I decided to think ahead and focus on children, the next generation. The sugar of choice throughout this presentation is sugar-sweetened beverages, or soft drinks, cordials, and some fruit juices as they are more commonly known. Overweight and obese children in Australia are currently predicted to be the first generation to have a lower life expectancy than their parents. In order to alter this prediction, dietary intervention is required. Recent findings from the Australian Health Survey identified that teenagers consume the largest amount of soft drink compared to any other population group. It was also revealed that throughout the world, the consumption of sugar-sweetened beverages has been increasing due to the availability and price of these products, with consumption consistently being above the daily recommended limit. In order to reduce the burden on society, the focus of this review will be on childhood overweight and obesity, and the effects of consumption of sugar-sweetened beverages on body weight. Many countries have developed their own dietary guidelines to provide the public with advice on what foods they should be consuming and how often. The Australian Dietary Guidelines provide healthy options for food choices based on scientific evidence. This includes guidance on the amount of discretionary foods that should be consumed, for example, added fat, sugar, and salt foods. Guideline 3 recommends to us limit intake of food and drinks containing added sugar such as confectionery, sugar-sweetened soft drinks and cordials, fruit drinks, vitamin waters, energy and sports drinks. The World Health Organization are also well known for developing leading guidelines in health and nutrition. 3 systematic reviews were collected to review the evidence contributing to the development of multiple nutritional guidelines. These were Dietary Sugars and Body Weight, Systematic Review and Meta-Analysis of Randomized Controlled Trials and Cohort Studies, Sugar-Sweetened Beverages and Weight Gain in Children and Adults, a Systematic Review and Meta-Analysis, an intake of sugar-sweetened beverages and weight gain, a systematic review. The last review is essentially the prequel to the second review, and although it is a bit older, I wanted to include it to see how the evidence developed since the first review. For the purpose of this review, I will refer to the papers of study 1, 2, or 3 as they appear above. According to the NHMRC evidence hierarchy, all 3 reviews are classified as Level 1 evidence, as they are all systematic reviews that have undergone a peer review process. Study 1 included randomized control studies, or RCTs, and prospective cohort studies, which are both Level 2 studies. Study 2 used RCTs and cohort studies, although with more cohort studies than randomized controlled trials. Study 3 used 2 RCTs, cross-sectional studies, and cohort studies. The search strategies were pretty similar between each study. Authors started by searching databases such as PubMed, Embase, Cochrane, and Medline. They then filtered out each study to make sure that they were only English language. This was done by 2 reviewers. They would focus on looking for outcome measures which included children's studies, BMI measures, and sugar-sweetened beverages. Exclusions were animal studies, age of the review, for example, it was a really old study, and minimum durations for interventions. If there are any discrepancies between the authors, an independent subject was brought in to decide. I will now talk about the quality methods and results of each study separately. Study 1. This review compared the effects of SSBs, or sugar-sweetened beverages, and body fat on both adults and children. It was developed according to the Cochrane Collection, which provides guidance to authors regarding best practice for systematic reviews. An array of databases were searched, along with hand selection of papers as to not exclude information. The search could be reproduced as it was produced using 2 independent authors, and any discrepancies were decided by a third party. 5 RCTs and 21 cohort studies were selected for children only. These articles were subject to a grade assessment. Grade assessments require that information was taken from a systematic review, which strengthens the evidence presented in this review. The outcome measures are clear and definitions are provided for key terms within the review to limit ambiguity. For the randomized controlled trials, poor compliance occurred in 3 out of 5 studies. The p-value and test for heterogeneity indicate that there is considerable heterogeneity occurring between the studies. After reading their results, their conclusions were consistent with the evidence found. The cohort studies found no heterogeneity, and after using a quantitative meta-analysis, a positive association was concluded. The odds ratio and confidence interval supported this. The authors are very clear about their limitations and don't try to draw conclusions where they are not available. Not being able to find RCTs that test an increase in sugar consumption in children due to ethical reasons was a limitation. Overall, the review provides good quality evidence. Study 2. This was the latest review and had the most up-to-date evidence. PubMed, Embase, and Cochrane were searched for articles up to March 2013, which included both adults and children. However, meta-analysis for each were produced separately. The search method follows the PRISMA statement. This adds to the quality of their chosen studies. Studies were selected using 2 independent authors, and discrepancies were resolved using a 3rd independent subject. The objective of the systematic review is very clear and doesn't try to include too many outcome measures. This review includes more figures within the review rather than an appendix tables. I found this helpful to determine quickly the quality of the evidence. The studies were broken down into country of origin, providing the number of participants for both genders. Definitions were also provided within the literature. The RCTs were assessed for quality using the Cochrane collection, and the cohort studies used the Newcastle-Ottawa scale. This scale judges studies on their selection of the study groups, the comparability of the groups, and the ascertainment of either the exposure or outcome of interest. This scale is still under an evaluation process, and although it does provide some quality assessment, it is not definitive. The cohort studies provided a combined 25,745 children, which is a large number and reduces selection bias. Multiple tests were applied to the cohort studies, including a pooled estimate, random effects model, fixed effects model, and stratified analysis. This ensured any heterogeneity was revealed between studies and variations could be accounted for. The same tests were applied to the RCTs and mixed results occurred. The authors acknowledged that this may be due to the size of the studies and the variation in intervention techniques, e.g. school education programs versus substitution of non-calorific drinks. Overall, the quality of the evidence is good. This review did include a double-blind experiment, which Study 1 did not. The limitations included variations in study design, leading to heterogeneity, and having to exclude studies due to non-comparable units of data. 3. This study was the oldest of the 3 and used the least amount of RCTs, meaning it has the poorest quality of evidence. However, I did include it as a comparison to understand the difference between good, up-to-date evidence and poor, outdated evidence. Medline was the only database search, which limits the range of reviews available. The inclusion and exclusion criteria were very clear, meaning the search terms could be replicated. Unfortunately, due to the amount of heterogeneity between studies, a meta-analysis was not able to be produced, which lowers this review's quality compared to Study 1 and 2. P-values seem to be the only reported measures for cross-sectional studies, which limits analysis of the evidence. Not to mention, cross-sectional studies are not ranked highly on the NHRMC hierarchy of evidence. The cohort studies include both p-values and confidence intervals, which provide a better analysis of the data. The 2 RCTs were also used in Study 2. Interestingly, a significant conclusion was found in this study. However, in Study 2, when a meta-analysis was used, no significant conclusion was found. Overall, the data is limited as only a few test values were compared. Greater insight may have been achieved with the creation of meta-analysis. In conclusion, 2 out of 3 of the studies provide quality evidence to support the reduction of sugar-sweetened beverages in children as a dietary intervention to reduce overweight or obesity. The 3rd study provides an example of poor evidence, which is helpful when comparing quality of evidence between studies. Thank you for choosing to watch my presentation.